Okay, class, we're going to work through an example that's going to be very similar to problem in chapter 10, problem number 7 that I assigned. There will not be one like this on the exam. I do want you to go through and work the problem and turn it in, because this will help you understand a little bit better what Solver is doing in the background. This is actually designed for you to do this manually first and then using Solver second, so you'll be able to see how this works. So I've made up a problem that's very similar. This problem is warehousing perishable ingredients. So I need to warehouse some caramel flavor, some soluble fiber, some saturated sucralose, some ascorbic acid. These are all things that are used to make soft drinks. And they do have legitimate spoilage rates. So depending on how you store some of these, like caramel flavor, for example, if you store it in a freezer, you'll lose about 2% in the span of 90 days. If you try to store it in a regular room temperature warehouse, somewhere between 15 and 20% will spoil in 90 days. So I made this table up of this is the amount of loss by storage type in the span of 90 days based off of thousands of pounds. So this is 88,000 pounds in stock, 40,000 pounds in stock, and so forth. Some of these cost a great deal. So caramel flavor is about $5 a pound, or $5,000 per 1,000 pounds. Or sorry, $50,000 per 1,000 pounds. $50 a pound is the cost of most caramel flavor. It's very expensive. So this is based on some real world stuff, and we're going to say to ourselves, okay, I'm a warehouse manager and I need to decide how much of this I'm going to store in each location. I've got about 500,000 pounds I need to store, and I have about 500,000 pounds worth of storage capacity, and I'm going to try to figure this out by hand. Okay? And this is the point of chapter 10, problem 7. So I'm going to go ahead and create an area here in which I'm going to populate my decisions, my populating of these warehouses. I'm going to go ahead and color it yellow and outline it like I like to, as if Solver were going to solve it. And these are my decision variables that I'm going to do. Okay, this is my decisions I'm going to make on what I'm going to put into this warehouse. Okay, now as I store into the warehouse, I need to know whether I'm running out of room or not. So I'm going to sum each column, and I'm going to sum each row. Okay, and what this is, this will let me see whether or not I have hit the capacity of that warehouse type. It will also let me see whether I have already stored everything that I have in stock into these warehouse types. Okay, now I then want to know, after 90 days, how much of this stuff do I have left of each item? I'm going to put a few dummy values in here. I'm just going to put ones in this one this time. I just want to know if my formula is doing anything at all. Okay, so I put ones in there. Okay, now if I want to know how much of this has made it, okay, so if I do 1 minus the loss, that's the amount that will be retained at the end of that period of time, times the amount that I stored. So I'll have 86% of that item left, so on and so forth. Okay, come on. So I'm going to paste special formulas. So that's how much will be remaining of each one of those items at the end. And now I'm going to sum again to see how much of each one of these I have left. Okay, and now I'm curious to see what the total tonnage retained was, total hundreds of thousands of pounds retained. Okay, curious up here how much I started with in stock as well. Okay, so I started with 499,000 pounds in stock, and this will end up calculating how much is retained after spoilage rates. And then finally, I want to know what my residual value is. So all these things are expensive, and what I want to do, I want to store in such a way to save the most money, not necessarily to save the most tons. So the residual value is going to end up being the sum product of this array, the remaining quantity of items, times this array, the original value per 1,000 pounds. Okay. do 0 decimals there. Okay, so this is set up now to be able to make a decision. I'm going to do it by hand first. I as a human think that I've really got some good ideas here. And one of the ways you can do this, and this is very common in lots of industries, is you will have what's referred to as a yield table. Okay. So these are my losses. My yield, I'm trying to maximize my yields of items, right? So my yield is equal to 1 minus my loss. Okay? And we just did that a minute ago. We're doing some formulas down there. But I'm going to keep it separated over here just so we can see it. So this is what somebody might refer to as a yield table. Now, one of the ways that humans will solve problems like this is say, okay, I'm here loading these warehouses. I'm going to load this warehouse up, and I'm going to go ahead and get rid of these dummy values so I know my formulas are working. Okay, and I'm going to say to myself, I'm going to look for my highest yields, and I'm going to start loading my warehouse with the highest yields first, so that I can preserve the most product and work down toward the lower yields. And you can already see a little bit of a problem. I'm going to have to decide. I've got two things that have a 99% retention rate that can go in a freezer. Okay, and then I got a 98 next, and I got another 98 here. So I'm just going to do my yields, and I'm going to start at the left-hand side just to have an arbitrary direction to go anytime I have two that match. And I've got a 99% on the soluble fiber right here. I'm going to bold it so I know I've used it or bypassed it. And I'm going to go over here and look at my soluble fiber. And I've got 40,000 pounds I need to store. And because it's a 60,000 pound capacity in this particular warehouse, the frozen warehouse, I know I can fit all 40,000 pounds in there. So I'm going to go ahead and put them all in there. And then I'm going to go back to my yield table. And I've got this other 99%. Okay? I'm going to bold it so I know I've already used it as a decision variable. I'm going to come back over here and say, okay, that means I'm going to put some of this saturated sucralose in there, and I've got room to put another 20,000 pounds in there. So now my freezer is full. Now I'm going to go back to my table and look for next biggest yields. I've got a 98 here, a couple of 98s here, a 98 here, and a 98 here. So I'm going to start with the one on the left, and I'm going to put caramel flavor into this refrigerated warehouse. Sorry, maybe back up. So I've already filled up my freezer. So now I can't use anything else in the freezer. So these two 98s are basically done. So now I look at my table, and you can see one of the challenges of doing it this way. It's easy for a human to make a mistake. But if I look back at my table, I've got 98s, 98s, 98, 97. Okay. As a human, I'm going to say, okay, because I've already started putting some saturated sucralose away, and I've got a 98 choice there, and I've got a 98 choice here. I'm going to go ahead and put some of the more of this saturated sucralose away because it's a 98, and I'm going to put it in this refrigerator 2 arena. You know what? In order to make this easier on myself too, I'm going to label these warehouse 1, warehouse 2, refrigerator 1, refrigerator 2, and freezer. Okay. So in refrigerator 2, saturated sucralose, I've got a lot of it left, and we've got enough room in refrigerator 2 to put 105,000 pounds total. So let's go ahead and do that. 105,000. Now that one's full, and I've used up this 98, and because now that building is full, I can't use any of those. So now I'm going to look for my next highest yields. I've got saturated sucralose again and ascorbic acid. Both are 98s in refrigerator number 1. Okay, so using my arbitrary rule of thumb I started a minute ago, I'm going to work left to right. So I'm going to go back to my saturated sucralose. I had 275,000 pounds to start. I've put away 125, so I still have 150,000 pounds I need to put away, and refrigerator 1 will hold 85,000 of those pounds. So I'm going to go ahead and put those all in there because I'm interested in maximum product yield, right? So now I've used up that one, and I'm going to go ahead and bold this whole row because refrigerator 1 is now full. Okay. Now I look for my next highest yields. So my next highest yields is a 97% again on the saturated sucralose and a 97 on the ascorbic acid. All right, and I'm going to look over here and see I've got 65,000 pounds more of my saturated sucralose I need to put away, which leaves 65,000 pounds worth of space in warehouse 2. And so I'm going to go ahead and put 65,000 pounds of the ascorbic acid in there. Now it's full. Okay. I'm going to go ahead and bold that because that building is now completely full, and look for my next highest yields. Okay, my saturated sucralose I don't need anymore. I've already put it all away. My next highest yield at 96% is ascorbic acid. So I'm going to go ahead and put this ascorbic acid away. How much more do I have? I started off with 96,000 pounds. So I'm going to do my 96 minus the 65 I already put away. So I put 31,000 pounds in there. My ascorbic acid is now taken care of. Okay, got quite a bit of room left in this this warehouse. So I'm going to go to my next highest yield, which is caramel flavoring. I've got 88,000 pounds I need to put away. I haven't done any of it yet. So I'm going to go ahead and put those in there and see how much room I have left. So I've still got about 41,000 pounds worth of space left in this warehouse for my final item, soluble fiber. And I already put all the soluble fiber away. So that's where we are. Now, out of curiosity, we had 499,000. I didn't put a sum down here. Did we manage to get it all in the buildings? We should have. Yep. So we've put it all away, and we put it all away in forced rank order of we want to preserve the product. Okay. So we believe that we have maximum pounds preserved based on a by hand yield based solution for this warehouse put away problem. And our residual value of the product is $4.2 million. Okay. Now I am going to move or copy that tab we just worked on. I'm going to copy it. Okay. I'm going to rename it. This is now like 10.7B, and if you're looking, you can see that. Whoops. That's what I wanted. Yeah. It's like 10.7B. Okay. Now this time, instead of me trying to do this by hand and coming up with the fact that I did put all 499,000 pounds away and I did retain 477,000 pounds of it at a value of $4.203 million, instead of me filling in these boxes, I'm going to let Solver fill in these boxes. And this is exactly what the problem is on 10.7. I'm going to delete this yield table because I'm not going to use it. Okay. Now remember what we did before. We've already got sums here, so we know whether or not we have put away everything in the by commodity. We've got sums here to know whether we have reached warehouse capacity. That's going to be two of our constraints in the solver model. Then down here, we've already put the formulas in for how much is retained, how much is left at the end of 90 days, how many tons did we retain, and what's that dollar value. Okay. So with all that said, we're going to go to data. We're going to open our solver. Okay. I'm going to reset all of these. Blink. Okay. And my objective is this residual value. I do want to maximize it by changing the values in these cells. Okay. I'm going to add a constraint. The amount of stuff, the amount of each commodity that I store must be equal to or less than the amount of each commodity I have. Okay. I'm going to add another constraint. How full each warehouse is must be less than or equal to the capacity of each warehouse. Okay. And in real life, there are such things as refrigerated warehouses and frozen warehouses. That is a thing. I'm going to click OK. And I'm going to solve. I keep the solver solution. Okay. And what we can see here is we came up with a little bit different solution with solver. Solver chose to put the products in different places because it was prioritizing the dollar value, not prioritizing the yields. So let's just tab back and forth here and take a look at it. So if you recall, all of our caramel flavoring ended up in a regular warehouse on the prior problem when we did it by hand, as you can see. And only 75,000 pounds of it survived. When Solver works on it, it prioritized putting that high dollar item, caramel flavoring, in the freezer first and then a refrigerated warehouse, and 85,000 pounds of it were retained. Okay? Across the whole solution here, you can see that 484,000 pounds were retained with the Solver solution. We as humans only managed to retain 477,000, even though in our minds, as we did it by hand, we thought that we were prioritizing retaining pounds by focusing on yields. We as humans came up with a lower total pounds preserved than Solver did. Similarly, the residual value of our solution as a human at $4.2 million was less than the residual value Solver came up with of $4.7 million. So that's a compare and contrast of how a human might solve a problem like this and how Solver would solve a problem like this. I hope that was clear, and we will look at it later.